In this video, we'll be graphing a system of inequalities. The system that we'll be working with is x is greater than or equal to 0, x plus y is less than or equal to 4, and 2x plus y is less than or equal to 5. What we're going to do is graph each of these inequalities individually and then look at where the three inequalities intersect. That'll be our solution to the system. Our first inequality, x is greater than or equal to 0, is all the points to the right of the vertical axis. So all points where my x coordinates would be positive. And since I have greater than or equal to, I have a solid boundary line. So my boundary line is my y-axis. And I'm going to be graphing all points to the right of my y-axis. My next inequality, x plus y, is less than or equal to 4. Let me change this to y equal mx plus b. So I have y is less than or equal to negative x plus 4. So my boundary line has a y-intercept of 4 and a slope of negative 1. Y-intercept of 4 and a slope of negative 1 means I'm going down 1, right 1. Since I have less than or equal to on the inequality symbol, I'm going to have a solid boundary line. So I need to connect all of these corners. Now to decide what side to shade on, I'm going to pick a point. Let me pick the point 1, 1. And I'll put that back into my inequality. 1 for x and 1 for y. And see if that's a true statement. So 2 is less than or equal to 4. That's a true statement. So I'm going to shade on the side of my point. My third inequality, I'll write that in slope-intercept form. So I have y is less than or equal to negative 2x plus 5. So I have a y-intercept of 5 and a slope of negative 2. Y-intercept of 5 and a slope of down 2, right 1. So down 2, right 1. Down 2. Or I could go up to left 1. This also has less than or equal to, so it's a solid boundary line. Now my point 1,1 is not on the line, so I can use that point to test which side to shade. If I put in 1 for x and 1 for y and test to see if that's a true statement. 2 plus 1. So 3 is less than or equal to 5. This we didn't know if this was true, but this is a true statement. So I'm going to shade on the side of the point that I chose. Now we need to determine our solution set. It kind of looks like a mess, but we can use what we know. We know that with our first inequality, we shaded to the right of our y-axis. So none of this shading is going to be part of the solution set. So it's got to be to the right of the y-axis. Also, my red shading was below the red line, and my green shading was below the green line. So my solution set is going to be all of this, all of this area where I'm shading in black. I have a little bit of a corner right here, so that's tricky. Other than that,